Okay, these notes are about scientific notation. Okay, so numbers written as powers of 10 is basically what scientific notation is. So we're going to take a huge number and we're going to make it a lot smaller, and then we're going to say how many powers of 10 it is. Kind of like metric conversions with moving the decimal. So we're going to be moving decimals here, and every time we move a decimal place, it's a power of 10, which is what decimals are. So first you're going to make sure you have one number in front of the decimal only. Something like maybe 3.89 times 10 to the 2 would be a number that's in scientific notation. But if it's like 389 times 10 to the 4, that number is not in scientific notation because it's got 3 numbers in front of the decimal, not 1. So it has to be just one number, and can't be a 0. It has to be an actual number in front of the decimal. Now, if your number is large, if it's greater than 1, the exponent's positive. Okay, and if the number is small, your exponent's going to be negative. Okay, so let's take a look at 621 million in scientific notation. So I'm not going to do the loop-de-loops to move the decimal on these. If the number is bigger than 1, it's super, super simple to put into scientific notation. You're going to find the very first number you see, which is the 6. You're going to put the decimal point there, and then you're going to write all of the numbers after it, not zeros. And so once you get to the last number, all of those zeros at the end, you're not going to write. That's the whole point of putting it into scientific notation. Now, if this was like 6021, maybe like this, okay? Then you would write 6.021. But it's not, so we're not going to. And hang on a second, let me erase that. Okay. So we have to figure out how many places of 10. So we're moving our decimal point from the end all the way to the 6. And I don't know about you guys, but doing the loop-de-loops like we did with metric conversions is kind of a pain in the butt. You don't have to here. All we're going to do is we're going to count how many numbers, including zeros, are after the 6. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So that's how many places we would be moving our decimal to the left, is 8 places. Because that's how many numbers we're bypassing. So this is 6.21 times 10 to the 8th. Okay, now let's look at this number. This one is a number that's less than 0. And it's a similar, we're going to do a similar trick, but the one main thing you have to do is make sure there is a 0 in front of that decimal. So if there's not, put 1 in there. Now, we're going to find the first number again, which in this case is the 3. So we're going to write the 3, and then we're going to write the 21 down. So we're going to write anything beyond it. When the number is less than 1, you have to write down that first number and everything that follows it, because there shouldn't be any zeros. And if there is, that means that 0 is important. We're just trying to get rid of the beginning zeros with scientific notation on a number that's less than 1. Okay, now we know our exponent's going to be negative because the number is less than 1. So we're just going to count the zeros, including that first one, which is why you want to put that first one there. So it's 1, 2, 3, 4, 5, 6. Now, if you don't believe me, let's just move it. So if we're moving the decimal, we're going to go 1, 2, 3, 4, 5, 6. As I said, I hate the little loop-de-loops. You kind of have to do it in metric conversions, but in this case, you don't. So I don't. So it's 3.21 times 10 to the negative 6. Okay, sometimes numbers are not in scientific notation, but they are with the power of 10. These numbers need to be put into scientific notation. So something like maybe 381.2 times 10 to the 10. That's not in scientific notation, but you need to put it in there. And I like to use a calculator. I mean, I can give you the rules if you want to know the rules, but really it's so much easier just to stick it in the calculator. Make sure though your calculator has an EE button if possible. If not, well, we'll have to figure out what to do. I can show you at school your particular calculator, and I can show you how to do the exponents without the EE button. But all you would do is, well, I'll show you on the next slide what you need to do. Okay, so what you're going to do is you're going to put in the calculator 396 EE4. What that EE means is times 10. That's what it stands for, times 10. So when you do that in the calculator, you get 396 with 4 zeros after it. Now it's easy to put into scientific notation. It's going to be 3.96, and there's 1, 2, 3, 4, 5, 6 places after the decimal. So there's your answer. Okay, and it's the same thing when the number is less than 1. You're going to put in 0.0921, okay, and you're going to hit EE5 and hit enter or equals or whatever your calculator does, and you get 9210. And then to put it into scientific notation, it's 9.21 times 10 to the 3. Okay? And that's pretty much it. It's really easy when you use the calculator. Okay, putting numbers into standard notation involves moving the decimal and adding zeros into these spaces, or just adding the proper amount of zeros before or after the numbers. Usually if you have a positive exponent, you add zeros so that you have the same number of digits after the first number as the exponent. If you have a negative exponent, you add one less zero than the exponent number. But there's a little trick. I actually add the same amount of zeros, but you put your decimal point between the first two zeros. And I'll show you on the next couple slides. Okay, so put 6.21 times 10 to the 5 into standard notation. Pretty easy. I'm going to write my 621. Now, I need 5 places, 5 numbers after the 6. And that includes the 21. And then I'm going to add zeros to make up for not having enough, because the 21 is 1, 2, right? I need 3 more. So 1, 2, 3, 4, 5. So it's 621,000 is what 6.21 times 10 to the 5 is. And if you want to double check yourself, just put the decimal point in there and count your spaces. 1, 2, 3, 4, 5. So we know we did it right. Okay, now on this one, we're going to put 3.01 times 10 to the negative 5 into standard notation. So I'm going to write my 301, because you have to include all of the numbers that are in that number before the times 10. So it's 301. I need 5 zeros in front of the 3. So 1, 2, 3, 4, 5. And then I'm going to put my decimal point between the first two numbers. Kind of like we did when we did the opposite. Remember, we counted the numbers provided there was a 0 in front of the decimal? It's the same thing here. We're going to put 5 zeros and then put the decimal between the first two. So hopefully that makes sense. Okay, multiplying and dividing in scientific notation. This is super, 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 super easy if you have an EE button on your calculator. If you don't, it's a little bit harder because you have to use parentheses. If you have an EE button, you don't have to use parentheses. So, and I'll teach you how to do it in class if you don't have the EE button. Okay, so here we're going to write down, in our calculator rather, we're going to put 3.02 EE5, and then we're going to hit the times key, and then we're going to do 2.01 EE6. And see what that comes out with. And when you put that into the calculator, you get 6.0702 times 10 to the 11th. Now, some calculators, when you read them, People are like, but I don't see times 10. They don't actually put times 10. So like this one would be, hang on a second. You're gonna, in your calculator, you're actually going to see 6.0702 and then a little e and 11. That means times 10. So the E button there means times 10. So that is actually that. So don't write this. This means nothing to me on paper. This only means something to the calculator. So you have to rewrite it as 6.0702 times 10 to the 11th. Okay, let's try another one. So this one's going to be 3.02 E5 times 9.11 E and negative 9. So now we're going to hit 3.02 E5 times 9.11 negative 9. And I get 0.00. Now, notice I'm writing the 0 in front because I still have to put the number in scientific notation. 27. And guys, don't go past 3. Really, you only need to write 3 numbers down unless I tell you otherwise. So this is going to be 2.75 times 10 to the 1, 2, 3, negative 3. Okay? Okay, now this is where the parentheses matter. If you do not have an EE button, you have to use parentheses, and I'll go over in a few minutes how to do that. But if you have the EE button, it's really quite simple. So you're going to put in the calculator 3.02 EE5 divided by 2.01 EE6, and you get 0.150, which is 1.50 times 10 to the negative 1. Now, if you put in your calculator 3.02 times 10 to the 5 divided by 2.01 times 10 to the 6, you're going to get something totally different because it's order of operations. Your calculator will do the multiplication, so it'll do the 3.02 times 10 to the 5, okay, and then it will divide by 2.01, but then it'll take that answer and multiply it by 10 to the 6. So you would get 1.50 times 10 to the 11th, which is not the correct answer. So you actually have to type in your calculator, parenthesis, 3.02 times 10 to the 5th, end parenthesis, and then do divided by parenthesis, 2.01 times 10 to the 6th, end parentheses. Then you hit enter or equals. Without those parentheses, your computer or your calculator is going to multiply, then divide, then multiply again, which is not what this problem tells you to do. Okay, this is the last one, last example. So this time we're going to do 3.02 EE5 divided by 9.11 EE negative 9. And when we do that, we get 3.3, well, I'll go to 3 places past, 315 times 10 to the 13th. Okay? And as I said, if you don't have EE button, make sure you're doing your parentheses because it's really, really important. Okay. Here are some practice problems. Try them on your own. I will have the answer key to them at school. We'll go over them when you get into class and see if you can get the right answers for them. Otherwise, have a good night. Bye.